All right, so we're live. So good morning, everyone. This morning's TST meeting is going to be used primarily for the purpose of reviewing the milestones for the Peacock release, which is scheduled to release in about 3 weeks or so, middle of December. And so I figured this would be a good opportunity to provide an update, especially before next week's ON.Lab Connect meeting. So just as a reminder here, let me put us to presentation mode. What happened here? Geez, am I missing something? Where's the presentation mode? One second. I don't see it anywhere. Where's the button? Somebody took away my button. Well, I guess we're just gonna have to do it like this, I guess. So I can't see it. Do you see it?
I don't see it.
Is it in the new UI?
Is it? Maybe, but there needs to be a big, huge button that says present.
Whatever.
Anyway.
Thomas, there's an arrow pointing down on the right. See that?
Arrow
on the menu bar on top. There's a arrow pointing down. I think you compacted the UI on top. See? There we go. Present.
That's it. Okay, thanks. Thank you. All right, good. Now we can resume. Anyway, so just as a reminder, the major themes of this release were primarily just to perform a platform upgrade, to embark on the initial code-based disaggregation, and to clean up the incubator area. So with that, I'm going to pass it to you, Ray, if you don't mind, representing the core and platform.
Sure. So since the last time we discussed this, the Carafe 4.2.1 upgrade is complete, and we did a little bit of Git magic so that we now have a 2.0 master head, which is what Thomas and I were working on before as a dev branch. And what was previously master is now 1.15. The plan is to do a 1.15 release probably before Connect, so hopefully this week. And then do the 2.0, as Thomas was saying, perhaps in a couple of weeks. We originally wanted to support Java 10 in this release, and we found that Bazel is not really quite there yet. They're still on Java 9, so we checked that out. Our stuff worked fine. Kind of the baseline supported Java is still Java 8. Our plan is to move right to Java 11 when Bazel does, because 9 and 10 have both been end-of-lifed by the powers that be.
If I can add.
So the build system is wagging the version of Java we use in our application?
Yes. Because the way that Bazel works is Bazel supplies everything you need to build, including the JDK.
All right. That's just a very odd dependency in some sense that my build system now determines.
No, it does.
What I use.
It strictly does not, David. We would have to jump through some hoops in order to be able to do compilation and to run unit tests with the recently released version of Java 11. The reason we're jumping to Java 11 because it's an LTS release, just like 8 was an LTS release. 9 and 10 are not. So this is something we didn't realize. So because at the time we made these plans, Java 11 wasn't yet released. So we're jumping straight to Java 11 because it's an LTS, but because the build tool does not have the full support for it, we're not moving to it until it does. Just because it's some energy.
I get that, and I'm okay with going to 11. It just something intrinsically bothers me when my build system has this much impact on a language choice I use to build an application. Right? internal. Don't worry about it. It's just weird.
Well, I mean, it's something that we can work through. It's just that it's not a worthwhile piece of energy because we know Basil's going to add support for Java 11, and all we will do at that point in time is do nothing, and it will just work.
Yep, I get that. It's just like saying, I want to use make, but I can't use make because it determines which version of C++ I use. That's the analogy in my mind. Don't let it. I don't want to dwell on it anymore. But yeah, that's just kind of where I am.
Okay.
Okay, so Thomas did a bunch of work and actually got rid of the incubator tree completely. There was some sort of dead-end science project-y kind of things in there that we got rid of. Most of everything else, I think, was subsumed into core, right, Thomas? Or did you break some off into apps? I don't remember.
Both into the core and into the apps and protocols as well.
Okay, so we the main motivation for this was I think incubator was a good idea, but wound up creating some very sort of tortured dependencies between core and incubator that we really didn't like. So it should be much simpler now. For now, we've decided to shelve the continuing source code disaggregation work. I think we've decided that we kind of want to go in a more aggressive direction in terms of what the next architecture of ONOS will look like. And I think doing some code disaggregation now would be putting the cart before the horse. I think we want to know where we want to go before we tackle the disaggregation, because we may end up with something that looks very different than what we have now. Managed to get sonar static analysis working again. That had gotten broken with the Basil tool because we had a lot of buck-specific stuff in our scripts. We still don't have coverage data, but we at least have static analysis again. The plan is to try to get coverage working before 2.0 goes out.
Yep.
Okay, Thomas, back to you.
Thanks, Ray. I think we can hand it over to Jordan.
Yeah, so for the distributed systems components, so I was focused on just upgrading to Atomics 3.1, which is the latest release for 2.0. And so some of the features that improves are, so it adds a messaging protocol handshake, which we can use, which is, I mean, the benefit of this is for upgrades, we can make changes to the protocol without breaking ISSU. Yeah, there's some new communication methods, support for UDP, which we use for some events to decrease the load on the network. New service discovery mechanism for Kubernetes, and a new membership protocol. So one of the issues we've had in the past is the current cluster membership protocol used in ONOS doesn't behave well in network partitions, and so SWIM is a much better protocol that accounts for a lot of different types of network partitions and doesn't have as many false positives, because what we've seen is false positives inside of ONOS can cause massive state changes, like massive zip changes and tons of other state changes after that. So there's a new membership protocol, optimizations to the RAF log, and then complete configuration documentation for Atomics, which I'll show later.
All right, thanks, Jordan. Right.
Are these Atomics changes going to be pushed back to older versions too?
No, so they're breaking changes. These are a lot of them, because of a lot of the protocol changes, they're considered breaking changes. Current versions, so 1.14, the promise has been that any release of 1.14 can work with any Atomics 3.0 release, and that would break that promise.
So okay, that's so the older versions
will be on
1.14, 1.15 won't be able to take advantage of these.
Correct.
Performance really updates.
Yep.
All right, thank you.
All right. Before here, is there something that you can talk about, or no? Do we have Carmel online?
Yes.
Okay, I didn't see you on earlier, so thanks.
Okay, so regarding P4Gen and MyEngine UI, so we upgraded the version of P4 N time supported as we approach the final release of 1.0. Now we support release candidate 3 with some minor changes in data types. as well as some new functionalities. So we support that. We did a major refactoring of Fabric.p4, and this was done to optimize the utilization of hardware pipeline stages. This is the the most important resource in our hardware pipeline, along with memory. So we went from 10 stages to 6 stages, and this was needed because we almost reached the limit, and we wanted to add new functionality like double VLAN cross connect. So we had to make space for that, and we were able to do so. So that's why we were able to also add support for a new functionality, which is indeed double VLAN cross connect. So we have support both on the P4 level and pipeliner level. We have initial support for GNMI. So we have a first implementation of a GNMI protocol subsystem that is very similar to the P4 runtime one. So we have a controller and a client now that allows to communicate with different devices using GNMI. We have a new Stratum driver that uses both P4 runtime and GNMI. So the behavior implementation is selected between P4 runtime and GNMI. And we are still working on adding initial support for getting port operational status notifications. Yeah, and regarding GNOI, actually, we didn't make any progress in that sense.
Is GNMI going to be a device driver, much like you called netconf or anything, so I can put it like in netconfig and have it as a base communication to a device?
Yeah, good question. So there is a GNMI driver in ONOS that I think right now doesn't provide any. Sorry, someone near the door. Yeah, so there is a GNMI driver. I think there is a behavior called device description discovery behavior. I mean, the bottom line is that yes, if you have a device that supports just GNMI and some other protocols, you can use the GNMI driver. But if you want to use, for example, a Stratum device that has P4 runtime and GNMI and GNOI, then you need to use the Stratum driver that has some internal logic that, depending on the type of operation you want to perform, decides if it needs to use P4 runtime or GNMI.
Okay. The interesting question here is, we're talking now about devices that essentially might have multiple connections from the controller using different protocols. Exactly. Right now, the controller is really focused on single device, single protocol, and it uses the break in that protocol to determine if the device is available in ONOS and all those good things. How's that going to be changing now that we have multiple connections?
Yeah. This is something we are realizing as we work on this. And our first finding is that I think the current driver subsystem, it's powerful enough to handle this this new scenario without impacting the layers on top of it. So, for example, we have a new device and shaker behavior that is the one that establishes connection to the device, tells you if the device is available. And basically what we do in the Stratum implementation of that behavior, we just call the implementation of the same behavior for the different protocols. And, we decide some logic. So, for example, when we want to establish a connection to the device, we call the device and shaker of both P4 runtime and GNMI. But for example, if you want to assess availability of a device, we only use P4 runtime because that's probably the most critical functionality we need for runtime control. So I think this is, our as I said before, our first finding is that the existing driver subsystem is flexible enough to allow using multiple protocols for the same device. Yeah, without changing.
And so, like when mastership changes, you have to tear down one connection on one server and bring it to the other.
Well, in the case of P4 runtime and GNMI, in the case of gRPC, we don't really tear down connections. Connections are all active. Right now, of all the 3 protocols, P4 runtime, GNMI, and GNOI, the only one that supports mastership is P4 runtime. So in this case, mastership operations are performed only using P4 runtime.
So if I have a cluster of 5 instances of ONOS, and I'm using GNMI, I have 5 GNMI connections to that device?
Yes. Potentially, yes. Actually, the way gRPC works is that as a client, you don't really have knowledge if your session to the device is open or not. If you're HTTP2, and so TCP session is open or not. That's completely transparent.
If I may intervene here, what Carmelo really is saying is that what they're choosing for the Stratum driver and for the base GNMI driver. Nothing prevents you, if you just want one connection to the device, to implement the device handshaker and a few other behaviors to really have just one connection and change it when the mastership changes. So when Carmelo says the driver subsystem is powerful enough, with the introductions of this driver handshaker, we moved part of the protocol, which was before in the provider, down to the drivers, and that enables you really to have multiple implementations, even of a protocol specific thing, like how many connections do I open. In case of netconf, it was the provider, so there was no way for each device to choose how many it would open depending on the number of ONOS instances. But here, since we moved the opening of the connection down to the device handshaker behavior with the GNMI device handshaker and P4 runtime device handshaker, that is one implementation. But you could have a Siena device handshaker, which uses GNMI and opens just one connection for the master and tears it down when that's not master anymore.
And this handshaker is new in 2.0?
No, it's actually been there since 1.13 maybe.
Okay.
Yeah.
I'll go in depth on this one if you want. I'm actually, just on a side note, I'm actually exploring the possibility of using GNMI for some OpenConfig based optical devices. So that's also something that's worth looking into.
All right, thank you.
All right. Well, thank you, Carmelo. This is great. On the UI, Sean's not going to be able to attend. At least I don't think he is. Just want to double check. But he still provided a demo which we can view later as a video. And he continues to work on the UI to pretty much single-handed right now. It continues to be disaggregated into various pieces. He actually moved to Angular 7. Original plan was to be on Angular 6. The UI 2 is now basically a separate module, not just library, but a separate extension, actually, which is built. Whose build is integrated with our Bazel build now, so it's just part of a build for 1.15 and 2.0. The UI framework itself is broken out as a library on the client side. And as part of this work, of continuing to integrate the various views and parts of the UI into this new scheme. The alarm UI has been added, which shows a list of alarms. And he started work on a topology view migration. Now, this work actually involves kind of a consolidation in two different dimensions. Not only is moving the topology itself to the new client-side libraries, but it also is dealing with merging of the Topo2 work. If you recall, the Topo2 work was started actually a couple of years ago, and it was intended to make the Topo view much more flexible and be able to support regions and progressive zooming and things like that. So Sean is basically using this as an opportunity to merge the Topo2 features with the old topology as part of this technology upgrade as well. And one of the things that was involved in this was moving to the latest version of D3, because D3 was previously using direct DOM object manipulations, which is something considered a no-no in Angular 6 and beyond, actually Angular 5 and beyond. And so in order to continue to use the D3 libraries, which are actually quite powerful and handy, we need to move to version 5 in order to comply with those conventions. And we can watch Sean's video later as part of the demo. All right, and QA, we will provide that.
Yeah, looks like I don't see John on it, so I can cover this. So I think for QA, John's been working on these two items. So first is to update HA test for separated atomic cluster. And then since we have upgraded to Craft 2.4, a lot of the CLI output has changed, and we had to update the regular expressions that we use in testdown to process this output to make testdown, to make the test work. And we do have another demo that will reflect some of the other work that we have done to make testdown tests running on physical network.
Okay, thank you. All right, I think that concludes the update portion, so we can move to the demo parts. Do you want me to give you presentation?
Okay. So, hello everyone. I'm going to give you a demo on running testdown tests on the physical network. So, as you all know, we have been using testdown for ONOS system testing, and we have developed various tests for ONOS, but most of the tests run with Mininet network. Until earlier this year, when the requirements to run separate routing tests on the physical part became a higher priority, and we started to implement this new feature. But instead of creating some hardware version of these tests, of all the existing separate routing tests, we decided to make some fundamental changes to testdown framework to make all the tests we have work on both Mininet networks and physical networks. So we can summarize the goal here. So first, we want to support running testdown tests with physical networks, and then the second goal is to run the same set of test cases with both Mininet and physical network by making minimum changes to the test logic. So to make that happen, the work we have done includes the following. First, we had to decouple Mininet from the test cases we have, and then we created libraries for hardware devices like OFPPA switches and some bare metal hosts. And then we migrated some segment routing tests to a physical trellis part. And we will use as our segment routing test as an example in this demo. So to explain how that works, I will give a very quick testdown overview. So to run a test, in testdown we have three files to define a test. We have a total file, a pi file, and a param file. So a total file is basically an XML file, and we can use this as our routing.total as an example. So a total file defines all the components that are required in this test. For example, in this file, we have an ONOS cell component, which corresponds to a 3-node ONOS cluster. And then we have a Mininet component that's located on the OCN node. And the .py file it defines the test logic. We further define, we split this py file into multiple test cases. And in each test case, we call the libraries from the drivers and the dependency files to build the test logic. And then we also have the params file, which it is where we put all the parameters that are needed by this test. So okay, so to make testdown talk to the components, and in this case it is the ONOS cluster and Mininet. We build drivers for different components. For example, we have the CLI driver and REST driver for ONOS. And we also have other drives to talk to Mininet CLI and Mininet hosts. And then the test file can just directly call these drivers, or it can group different drivers into dependency functions. So this is basically how Teststone works. But with physical networks, first, of course, we need to build new drivers for physical networks, physical devices. Like we have ONTPA switch driver to talk to ONTPA switches. And then we also have host driver to talk to hosts without going through Mininet. And then, but that's not enough because if you remember our goal, we really want to use the same test file to run on multiple network environments. So at some level, we need to provide like the unified API for the test. So to do that, we just replace the role of Mininet drivers in the test by a new network driver, which will then talk to Mininet driver or hardware drivers, depending on how we define the total file, which we will see in a second. So for example, if we want to run this as a running test on the physical network, we simply just create a new total file. For example, this .total.flags. So in this new total file, we exclude the Mininet component, and we put all the other hardware devices here. For example, we have ONTPA switch. Well, this is a simplified total file, but I'll show you the real one in a second. And we also have a host here with the IPs and credentials to access these devices. So and then with this new total file, you can just simply call it from command line by using the name of the file as an argument. I will now give you the demo. Okay, I'll make it. So as you can see, I'm going to run SR routing, and with this new total file, maybe before I start, you can just show the new total file here. So this one is the .total.flags and has the ONOS cell component and also a lot of switches here. Basically, these are all the switches we have on the Trellis pod, which is located in Flags. And we also have some hosts here. And if I go back, so I will use this double file and also use customized params file because some of the parameters are different from running Mininet. I'll start the test. And at the beginning, it will try to, Teststone will try to connect to all the components defined in the total file. It will take a minute. And then after it connects to all the components, it will reinstall ONOS cluster, and then it will assign all the switches to ONOS, and then we will see that from the UI. Okay, so it's now installing Atomics. Okay, now it's installing ONOS. So I don't guarantee the test to pass because the pod we have in Flags is not ideal for automated testing because some of the servers don't have management IPs. So I need to connect to those servers from data plane. But data plane connectivity is what we test in this test. So it's a little tricky here, and so it's also a little unstable. But anyway, as we can see, it already okay. 10 more seconds. But we will see that all the switches will show in the UI, and then later the test will do a ping all, and then exit, hopefully. It's starting second routing, and applications are activated. It is posting the configurations to ONOS. Okay, now it is restarting the OF agent on the switches and connect the switches to ONOS. We'll start to see the ONOS the switches up here. So and you can see these are physical switches located flags. Okay, so far so good. And then the test will verify that all the hosts here have IPs assigned. And then it will do a ping all. Hopefully, we should see some traffic. I increased the size of the ping packets in order to see the traffic. Okay.
Christmas tree.
Well, no. Okay. I think it passed. It's now disconnecting the switches and the hosts. It's basically tearing down everything. Well, that's it. I think that's all.
That's really cool.
Yes.
I like the fact that you can just, because you can develop your test scenarios with Mininet, right? And then just apply a different recipe to connect it to one. And then,
Yeah.
it's nice, I like it.
Okay, thank you.
Right, thank you. I think, Jordan, do you want to go next? And then we'll play Sean's video afterwards. You and me.
Do I need to give back?
No, I think we can probably steal it from here. Okay. Everybody can see the demo matrix, right? I think if you have to go from the cancel presentation,
Yeah, so I don't have too much to share, but what I did want to share is, so since we've moved Atomics to a separate cluster, there have been a lot of users with various configuration issues. So as part of the second half of the work for this release, I went through and really meticulously documented every option for setting up Atomics and every option for setting up the ONOS cluster. And so what this file comes as part of the Atomics distribution. So when you download the Atomics server and want to run it, inside there's like an examples folder, and this file is called reference.conf. It literally lists and documents every possible option. So, and it shows how you can use like multicast for node discovery, configure the Atomics nodes, how you can set up the protocol. So like I said, we introduced the SWIM membership protocol. It shows how you can configure that protocol in Atomics, configure messaging connection pools, things like that, bind to private IPs, and everything else. How you set up the partition groups, all the available Raft options, and compaction, different types of partitions, and even configuration options for individual primitives. So you can use this actually as a way to optimize specific stores inside of ONOS, even though they don't expose configuration options. Yeah, so that's it. Just wanted to share this. And this is actually also available on the Atomics website. In the documentation, there is, it's also on the Atomics website of this every single configuration option document. So it's pretty much the same documentation. And so I sent that out to the ONOS dev group just so that everybody know about it. But hopefully this eases pain for users.
I don't know. It's awesome.
Yeah, that's really nice.
All right, and I think for the last demo, we're gonna watch the play the UI video that Sean kindly recorded. So.
Okay, I wanted to give an update on the GUI 2 work that's been going on with ONOS. So this is basically migrating the ONOS GUI onto a more modern version of the Angular framework. So previously I gave an update, and there are slides and videos available from this in Google. I guess what has been achieved since we've moved to Angular 7, we've moved the build and test and linting to the Bazel framework, the new build framework for ONOS, replacing Buck. We have moved the GUI framework out into its own Angular library or NPM library. The alarm view GUI has been implemented, and that's also been separated out as an external application. And then we started the topology view migration. That's a big work there. The topology view is one of the biggest parts of the ONOS GUI. So let me just change over to my editor here. I just wanted to show the structure. So this is the old GUI under the GUI folder. GUI 2 is the new application, and here is the framework separated out as its own library. So now it's built separately, and it's a dependency in this GUI 2. So let me just go into this GUI, and I'll look at the Bazel build file, replacing the Buck file. And you can see here we're using gen rules and basically using it to call on Angular build and Angular lint and Angular test and all of this kind of stuff. So basically it's just wrapping Angular CLI. The more complex approach of using Bazel targets for Angular directly hasn't been used here, because really those plugins and tools aren't really at a maturity level that you could use them in production. But this is something we'll look at in the next release. So just to look quickly at the framework library. So basically, it's the code now has been moved here to this location. So all of the familiar things like the layer, the navigation menu, those components, services, directives, and classes, base classes have all been moved here, and basically they're all bundled up together, and there's a public API file to export those. And when they're built, they can be reused in any project. Here, for instance, they're imported into this GUI project with this line here. So in package.json, you say, I want to use the GUI 2 framework library. You give it a location where the file is, but this could have been uploaded to NPM as well. It allows great flexibility in components of it. Okay, you can also see here we've upgraded to Angular version 7. Here as well, you can see that the FM GUI, the alarm management view, has been imported here as well, and that's also done through the similar kind of mechanism that's defined in fault management here under FM GUI 2 Lib, and again it's the same kind of a structure, whereas under projects, and that has two components, one for the alarm details view and one for the alarm tail view. So let me just, I was just going to quickly show the topology view work that has started. So here in the GUI, we've kept the hierarchy of the old GUI application, but this may get rearranged at a later date. But for the moment, it's buried down in source, main, web app, app, and here under view, we have the topology view. Okay, so let me just discuss that. Let me bring it up here. It's running in the background. So the topology view is really just at a very, very early stage here. So not all of the panels are ready. Let me just refresh this just to bring it back to its reset view. What we have here is we have the instances panel, summary panel, and here we have some nodes which have been laid out using a force graph. So the nodes are draggable, just as before, and here the hosts, because we're just hasn't been implemented yet, the hosts are just being displayed by a circle. But this is getting it from the back end, and when I select on a switch here, it basically brings up the details panel. So I've got keyboard shortcuts implemented, like say L is what I'm going to press here, and it brings up a toggle of the labels for the switches. And also I can toggle the instances panel. I can toggle the summary panel and the display panel. What I've done here is I have a layered approach for the topology view. So devices are not connected as one layer. The force graph is another layer. The background map is another layer, and this is basically just an SVG map of Croatia. Just to demonstrate the concept. So in addition to the dragging of nodes, I've implemented the zoom as well. So using the scroll wheel, I can zoom in and out, and also pen by dragging across on the viewport as well. So just to discuss a little bit about it, the topology here has been laid out in this hierarchical fashion. So we've got the panels, each one has their own component, and so on, and then the layers, each one has their own component, and then some of them, like say that force component has its own child components beneath it. So basically there's one for displaying a device icon, one for a host icon, one for a sub-region, and the link gets its own component as well. So very modular, very controllable, and of course each one of these components is addressable and reusable, and kind of runs in its own sandbox. Its CSS is not, and its HTML template is not shared among other components and can be loaded and unloaded dynamically. So this is a big change to the topology view in how it's implemented. By comparison, I was just going to bring up the old Topo2 view, which let me see, app and view and Topo2 is a very flat model. There's one HTML and two CSS files for all of the services, and everything here is a service. So the new approach is to structure the thing in a far more kind of logical way. Now, as you probably know, in the old GUI, there was a topology 1 and a topology 2, and I think all of the features of topology never got migrated to topology 2. But that's what we're aiming for here with this GUI, is to migrate everything across and have the best of both parts merged into one. And the topology 2 brings new features like regions and sub-regions and navigation, a hierarchy effectively of views to deal with large networks. So that's something that topology is going to implement as well. There was one other thing I just wanted to cover is in developing these, I used Angular CLI, but what I'm also using here is IntelliJ IDEA Ultimate Edition, which has support for TypeScript. The Community Edition doesn't have support for TypeScript, and basically what you end up with is all grayed out text, and there's no context sensitivity at all in the Community Edition. So for anyone developing in TypeScript, I would say the Ultimate Edition is well worth the license cost for it. It's a pretty modest license cost. Okay, just to go back to this view, what I wanted to do as well is just quickly show the alarms view. The alarms appears here because I have the fault management application loaded, and really it's just a tabular layout where the details pop in. That comes in at the sides there, and context sensitivity will be added to this as well, that will allow you to go to the device view from it. Just to quickly go back to the slides, what I wanted to just follow up with is there's a couple of screenshots that we've seen already, is the next tasks. Okay, so the topology view, we're looking at fully implementing regions and sub-regions and breadcrumbs, implementing the toolbar and all of the functions it has, looking at background maps and getting all of those loaded in the menus as previously, respecting the latitude and longitude and fixed positions of nodes, dealing with layers like packet and optical and that kind of stuff. And then there's a bit of Java backend work as well, in terms of getting the Topo 2 Java backend up to the same level as topology. Unfortunately, it's not there, so that will take some work too. So still a lot of work to do in the topology view to bring things up to par. But that's really where it is at the moment. So as with all of these things, any help would be greatly appreciated by anybody that's interested in getting involved in the GUI 2 project. Thank you very much indeed.
Oh, this is impressive.
Yeah.
This is really impressive. He's pretty much doing this single-handed now. Unfortunately, because Stephen had to disengage a bit.
Yeah.
Hey, if you're listening to this review, thanks again, Sean. This is excellent work. I think with that brings the mini milestone review to conclusion. Just again to iterate, one point that Ray mentioned earlier is we're decided not to do the code-based disaggregation. And the primary motivation for this is to leave the 2.0 release as stable and as solid as possible. And we felt that if we were to embark on the code-based disaggregation, we would be able to finish it in this release, and we would much rather spend the energy moving forward to investigating new architecture. And so that was deliberately omitted from the release, and possibly from future releases unless somebody decides to take that on. All right, well, thank you very much, everybody. Again, the reminder, the code freeze will be at the end of next week. And we're planning to start, at that point I'm planning to start the RC process towards the ultimate release sometimes in the middle of next month. Thanks again. We'll see you in hopefully next week at ONF Connect, and if not, in a couple of weeks at the TST meeting. Bye-bye.
Thomas, just a quick question.
Yes.
Do we want to discuss about 1.15? Just remind me.
It was, yeah, Ray already brought it up earlier. So 1.15, so it's a good point. We've done an RC release yesterday, RC2 actually, for 15. And then depending on the results from QA, the idea is to release sometimes this week, either tomorrow or Friday, depending on what the verdict is.
Okay, sounds good.
All right, thanks, Lucifer.
Thank you.